All right, let's get right into it. Today we are tackling what might just be the single most mind-bending, most important experiment in all of physics. It's called the double slit experiment, and, well, it's the place where our everyday common sense view of the world just completely falls apart. And hey, don't just take my word for it. The legendary physicist Richard Feynman once said this experiment has the heart of quantum mechanics in it. And believe me, he was not exaggerating. If you can wrap your head around this one experiment, you've basically got the key to the entire quantum world. So, what is this big mystery? You know, this isn't just some tricky concept from a textbook. It is a genuine, deep puzzle that completely stumped the greatest scientific minds and showed us that reality at its very core is so much stranger than any of us could have possibly imagined. And the amazing part? The setup itself is ridiculously simple. Seriously, you just take a barrier, you cut two little parallel slits in it, and you fire something at it. Could be electrons, could be photons, whatever. Then you just put a screen on the other side to see the pattern of where everything lands. That's the whole setup. Okay, so before we get to the wild results, let's just think for a second about what should happen based on our normal, everyday experience. In our world, things basically travel in one of two ways. Either they're a particle or they're a wave. So on the left here, you've got particles. Think of them like tiny marbles. You shoot them at the slits, they go through one or the other, and you end up with two distinct bands on the screen. Makes total sense, right? But on the right, you've got waves. Think of ripples in a pond. When they go through two slits, they spread out and interfere with each other, creating this really distinct pattern of many different bands. So the takeaway is simple. Particles make two lines, waves make a bunch of lines. All right, you've got those classical expectations locked in your head? Good, because now we're going to look at what actually happens in the quantum world. And this is where it all gets incredibly weird. So scientists fired electrons, which we all know are tiny little particles, through the slits. And what did they see on the screen? Did they see two bands? Nope. They saw the interference pattern, the exact pattern you would only expect to see from waves. Somehow, these little particles were acting like they were waves. And if you think that's strange, it gets so much weirder. Physicists thought, well, maybe the electrons are just bumping into each other. So they tried firing them one at a time. An electron leaves the gun, travels all by itself, and hits the screen as a single dot. Then another one goes. But as these dots build up over time, that same wave pattern emerges, dot by individual dot. It's as if each single particle somehow goes through both slits at the same time and interferes with itself. And get this, it's not just for tiny electrons. They've done this with huge molecules made up to 2,000 atoms, and the same thing happens. Just when you think your brain can't handle any more weirdness, it does. Because, of course, the physicists were dying to know what was going on. They said, okay, we have to know which slit each electron is actually going through. So they decided to peek. They set up a tiny little detector right at the slits, and its only job was to record if an electron went through the left slit or the right slit. Pretty simple, right? So what do you think happened to that wavy interference pattern on the screen? The moment they looked, the pattern vanished. Poof, gone. The very act of observing which slit the electron went through forced the electrons to stop acting like waves and start behaving like normal, boring particles again. They just formed two simple bands on the screen. Reality itself seemed to change just because it was being watched. And this whole thing perfectly illustrates a core idea in quantum mechanics called the complementarity principle. It basically means that a quantum object, like an electron, can be a wave or it can be a particle, but it can never be both at the exact same time. You can either know its path, like a particle, or you can see its interference pattern, like a wave. You just can't have it both ways. Now, for a long, long time, this was all seen as this mind-blowing paradox, a fundamental limit on what we could know about the universe. But in the modern era, physicists have started to look at it differently. They've begun to see all this quantum weirdness not as a problem, but as an incredible opportunity. And that right there is the key shift in thinking. That strange ability of a particle to act like a wave going through both slits at once, it has a name. It's called superposition. And it turns out it's not just some philosophical brain teaser. It's a real, tangible resource that we can actually use to build things. Which brings us right to the quantum future. The very same principles that seemed so baffling in the double slit experiment are now the bedrock for a whole new technological revolution that's happening right now. Researchers all around the world, folks like Professor Chaoyang Liu, are on the front lines of this. They are taking these abstract, weird quantum rules and are building real-world technologies that, honestly, used to be pure science fiction. So, for example, his team set a world record by linking 18 quantum bits, or qubits. Now, a normal computer bit is either a 0 or a 1, but a qubit, thanks to that superposition we just talked about, can be a 0 and a 1 at the same time. His team linked these qubits together using something even weirder called entanglement, a kind of spooky connection between particles. These are the engines that are going to power the quantum computers of the future. They've also used these ideas to achieve quantum teleportation. Now hold on, we're not talking about beaming people up Star Trek style. We're talking about instantly transferring information. By using those entangled particles, they managed to teleport the exact quantum state of a photon from the ground all the way up to a satellite over 1,200 kilometers away. That is a massive leap towards creating a super secure global quantum internet. And maybe the most impressive thing of all, they built the Zhejiang quantum computer. This incredible machine uses the very same wave-like properties of light we saw in the experiment to perform a calculation that is, for all practical purposes, impossible for even the fastest supercomputer on the planet. It's called quantum computational advantage, and it is definitive proof that harnessing all this weirdness can lead to unbelievable new powers. So, in the end, the double-slit experiment did way more than just confuse a bunch of physicists. It literally tore open our understanding of reality itself and handed us a brand new set of rules to play with. It showed us a bizarre world of probabilities, superposition, and spooky connections. And the question it leaves us with is this. Now that we've discovered this strange and powerful new layer of reality, what on earth are we going to build with it next?